Hello friends, welcome to engineering tutorial. In the previous video we discussed about the basic concepts of nodal analysis and we discussed one problem I think related to that. In today's video we are going to discuss another problem to clear our basics related to nodal analysis. So here we have a circuit which consists of two independent current sources of values 14 ampere and 7 ampere on the two ends, and we have a resistor network which is in the shape of a pi. Well, that is not important. So we have to find the nodal voltages at points 1 and 2. Now we have to do it using nodal analysis. Okay. So we have already discussed that nodal analysis is based on KCL. Okay. So we have to first write the KCL equation and then convert it into nodal voltage form. Okay. So let us see. Here let us assign some current directions and notations. Okay. I'm terming this current as I1 flowing downward through resistor R4, and I am terming this current as I2 flowing from 1 to 2 through 5 ohm, and I am terming this current as I3 again flowing downward through 5 ohm resistor. I1, I2, I3. Now we have to write the KCL equations for node 1. For node 1, the KCL equation is something like this. See, 14 ampere is flowing towards the node, so it will be on one side. I1 and I2, they are flowing away from the node. Okay, node 1 I am talking about. I1 and I2 are flowing away, 14 ampere is flowing towards. So 14 ampere will be on one side, I1 and I2 will be on the other side. Now we have to convert it in the form of nodal voltages. Now in the basic nodal voltage basics video, we have already discussed that current always flows from a higher voltage point to a lower voltage point. Okay, the expression for current between 2 points is VH minus VL divided by the resistance between the high voltage and the low voltage point. So here also it will be the same thing. The current I1 is flowing from node 1 to ground. So it will be voltage at node 1 minus voltage at ground divided by 4 ohm. We know voltage at ground is 0 volt. So it will be simply V1 minus 0 by 4. I2. The current I2 is flowing from node 1 to node 2. So it will be the voltage at node 1 minus voltage at node 2 divided by 5. V1 minus V2 by 5. Okay, now this is equal to 14. So now let us take the LCM. It will be 20. So it will be 5V1 plus 4 into V1 minus V2. Okay, so that implies 5V1 plus 4V1 minus 4V2 by 20 is equal to 14. Okay, that implies 9V1 minus 4V2 is equal to 280. Okay, so here the 20 in the denominator gets multiplied with 14 on the RHS, and this is 5 plus 4V1, which is 9V1 minus 4V2. So this is the first nodal equation that we got. Okay, from node 1, KCL at node 1. This is the first nodal equation. Now let us determine the second nodal equation. So now we have to determine the nodal equation for node 2. So here also at node 2 we have to apply KCL. So here if we see, we get that I2 is flowing towards the node, okay, it is flowing towards node 2, and I3 and 7 ampere they are flowing away from node 2. So the KCL equation will look something like this. I2 will be on one side and I3 and 7 will be on the other. I2 is flowing towards the node, that's why it is on one side. I3 and 7 they are flowing away from the node, that's why they are on one side. Now we have to convert it into nodal voltage form, because current is flowing from a higher potential to a lower potential divided by the resistance in between, as we did before. So I2 will be V1 minus V2 by 5. I3 is V2 minus ground by 5. V2, that is voltage at node 2, minus ground by 5. So it is V2 minus 0, as voltage at ground is 0, it is V2 minus 0 by 5 plus 7. Okay. Now let us take this V2 by 5 and move it to the LHS. Okay, so V1 minus V2 by 5 minus V2 by 5 is equal to 7. Okay, so the LCM here is 5 because both the denominators are 5, so it is V1 minus V2 is equal to 7. That implies V1 minus 2V2 is equal to 35. V1 minus 2V2 is equal to 35. Why? Here it is V1 minus V2 which is V1 minus 2V2, and this 5 in the denominator, when it goes to this side it gets multiplied with 7. So this is the second nodal equation. Okay, let us write it down here. So it is V1 minus 2V2 is equal to 35. Now we have to solve these two simultaneous equations to get the values of V1 and V2. Now there are various approaches. First one is substitution, variable cancellation, Cramer's rule. It's your choice. So here we are going to go with variable cancellation first, and in a separate video I will demonstrate how to use Cramer's rule. Okay, so let us go for variable cancellation method to determine V1 and V2. So here we have the two nodal equations, okay, for node 1 and node 2. Now we have to solve it using variable cancellation method. In this question we are going to go for variable cancellation method. Okay, so we have to cancel out one of the variables. So here if we multiply equation 2 with 2, suppose we multiply equation 2 with 2 and then subtract it from 1. So it will be, when we multiply equation 2 with 2, we get equation 2 multiplied with 2, we get 2V1 minus 4V2 is equal to 70. Okay, this is the equation. Let's call it 3. Now equation 1 minus equation 3, we are going to subtract these two equations, equation 1 and equation 3. So it will become, this is equation 1, 9V1 minus 4V2 equals to 280, and equation 3 is 2V1 minus 4V2 equal to 70. So when we subtract, it becomes minus, minus minus becomes plus, here it is minus. So it is 7V1, 4V2 minus 4V2, they get cancelled out. 280 minus 70 is 210. So 7V1 is equal to 210, that implies V1 is equal to 30 volt. So we got the value of V1. Now what we have to do is we have to just substitute the value of V1 in one of the equations and we'll get the result. Let us substitute it in equation 2, the value of V1. So we got the value of V1. So it is In equation 2 it is V1 minus 2 V2 is equal to 35. That implies 30 minus 2 V2 is equal to 35. That implies minus 2 V2 is equal to 35 minus 30, which is equal to 5. That implies V2 is equal to minus 2.5 volt. This is the value of V2. So V1 is equal to 30 volt, V2 is equal to minus 2.5 volt. Here we substituted the value of V1 in equation 2. This equation 2, V1 minus 2 V2 is equal to 35, and we got the value of V2 as minus 2.5 volt. Okay, so the nodal voltages here at node 1, V1 is 30 volt, at node 2 the voltage is minus 2.5 volt. Okay, so this is the second question related to nodal analysis which we have discussed.